Alright, in this video I'm going to be using trigonometry to solve a couple right triangles, one in which I'm solving for a missing side and one in which I'm solving for a missing angle. So let's take a look at this one where I'm missing this side. I have that this is a right triangle, this angle is 20 degrees, I have one of my sides is 12, and I'm missing this side right here, so I want to solve for x. So when I have a triangle related to my angle, we can call these sides something. If this is my angle, this is what I would call my opposite side. This is across from the 90-degree angle is what we would call our hypotenuse. And the side next to the angle that's not the hypotenuse is what we call the adjacent side. Okay, so if I think of my trigonometric functions, I've got sine, cosine, and tangent, and then I've got all of the reciprocal functions as well. If I have 20 degrees and I have the opposite side and I want to find the hypotenuse, I'm thinking about the opposite over the hypotenuse, which if I think of SOHCAHTOA to help me remember my trigonometric functions, I'm going to use sine to solve for that. I could also use the reciprocal function. In this example, I'll just go ahead and set it up with sine of my angle, which is 20 degrees, should be equal to my opposite, which is 12, over my hypotenuse, which is x. So once I set that up, I can use this to solve for x. So I can multiply both sides times x, move the x over to the other side, and then I can divide by the sine of 20 degrees. And x will equal 12 divided by sine of 20 degrees. So as long as my calculator is in degree mode, let's go ahead and do that. 12 divided by sine of 20 degrees gives me 35.0857. So if I want this accurate to 3 decimal places, I can either round and say 35.086, or I can truncate and just chop off everything after the third digit and say 0.085. So I would take either of these two answers would be correct on a quiz or unit exam. Okay, example number 2. Let's talk about what happens when I have a right triangle again, and I'm given two sides, but I'm missing a specific angle that I'm looking for. Okay, so let's label our triangle again. If this is the angle we're talking about, theta, then this side over here that I don't have would be my opposite side. The one across from my 90-degree angle is my hypotenuse, and this would be my adjacent. Now remember, this would change if we were talking about this other angle, but if this is the theta that I'm looking for, then this is the opposite, hypotenuse, and adjacent. Okay, so I have the adjacent and I have the hypotenuse. So if I set up and think of my trig functions right here, adjacent and hypotenuse would be cosine. So if I take the cosine of theta, that should be equal to adjacent, 6, over my hypotenuse, which is 8. Alright, now I want to solve for theta though. So in the last example, I had x over on this side, and I could just use algebra to solve for x. This time, my unknown is inside of my cosine. So what I really want to do is solve for my input here and solve for my angle. And so remember, when we're solving for angles, that we can use the inverse trig functions. So instead, I could rewrite this as inverse cosine of my adjacent over hypotenuse. Inverse cosine of 6 over 8 should give me my angle corresponding to those sides. So I'm going to plug this into my calculator. Inverse cosine of 6 divided by 8, and that gives me theta should be equal to 4096. So again, either rounding or truncating, I could get either 41.4, oh goodness, 410 or 41.409. Either one of these I would take.